Hello and welcome back. So this is part 2 of this short video series on making a simple game using HTML5 JavaScript for first-time gameplay programmers. And what we covered last time, just a quick refresher in case you took a break, we showed some real straightforward HTML, including a script element to put JavaScript in. We created a file and renamed its extension.html, dragged it into a browser. I'm using Chrome, but you can again use Firefox, Internet Explorer, doesn't really matter. And then we saw that in our JavaScript console, it would show us errors if we had a typo in our code, or otherwise it would show us our console logs and which lines those came from. Now what we're going to start doing is we're going to start adding some graphics and other functionality to the program. And this is going to take a few little steps to get there, but bear with me. First off, we no longer need this text at the top, or at least we don't need all that text. Let's just put some text here. Doesn't really matter, not terribly important. Let me zoom in on what we're doing in this area. And the first thing I want to show is something called window.onload equals function. This little bit of funniness right here. The way that this works is a special thing that we can do in HTML5 JavaScript specifically that says that as soon as the window finishes loading, that's what this window onload is bit, run the function or the series of code described between these braces. Now, what all that means might sound like a bunch of Greek if you're new to programming, but the gist is that we don't want our code to actually start running for our game until all of our page, and therefore all of our code is finished loading. This allows us to be a little more loose and free about the order in which we define functions or blocks of code that we then want to use. So we're going to start off with it here, saying we don't want any of this code to activate until it's finished loading and then run it. Otherwise, what happened when we didn't have this qualifier around console log, when the code got to the console log, it was running. Now it's going to happen only after the page finishes loading. We're going to be adding what's called a canvas element, which is where our graphics are going to be taking place. So up here in the HTML section, not within the script, we're going to create canvas ID equals game canvas, width equals 800, height equals 600. I'm going to close it, and then I'm going to do a close tag right after it, /canvas immediately after. And all this is saying is we're going to have a block for graphics on the screen for our game, really. That's dimensions are going to be 800 pixels wide by 600 pixels tall, and that's of course a good, pretty standard size for a game. It'll still fit on small, older laptop screens, but it's not so tiny that it looks terrible on a newer monitor either. And this ID game canvas is a label that we'll be able to use within the JavaScript to display graphics onto it. Now the next thing we're going to have to do inside script is we're going to declare two different variables, var canvas and var canvas context. Canvas is going to be a handle on the information about the dimensions of our display area. Canvas context is going to be sort of its underlying graphical information that we can then draw rectangles and circles or images to. Inside of our window onload function, and we want it here because it means the page is already finished loading, we're going to fill up canvas, that variable we set up right here, with document.getElement by ID. Make sure you lowercase the d in ID. I see people make this mistake all the time. Working is case sensitive in a lot of cases. And the argument here, let me decrease my font size. There we go. Just trying to avoid meaningless wrap where we don't need it. So inside these quotes, or single quotes, I'm going to say game canvas. And this corresponds to the label up here in the ID. This is what's going to give us a handle in our JavaScript onto the canvas element on our HTML page. And next we want a handle to our canvas context that we can draw graphics to. For that we're going to say canvas.getContext 2D. And just two more lines and I'll go back and explain how each one of these things is working. The next time we're going to say canvas context.fill style equals black is a terrible typing today. Black is one of the built-in colors we can recognize. We can program our own colors later, but that's the gist. And then canvas context.fill rect, which is short for fill rectangle, 0, 0, canvas width, canvas.height. There we go. I'm going to Control S or File, Save here, to save the page. And now when I go back to my browser, which still has this open, and if it doesn't, I can drag the file from my folder directly onto the browser. When I refresh, here's our text up here, and then here's our black canvas area with our console off to the side. Maybe we can shrink our console, doesn't need that much room, but it'll be good to have it handy to look at later if we see errors. So this black area is where we can then draw our game elements. And here's how this all works. So var is short for variable, which in code is just the way you create a container that you can then reference throughout, or you can reference elsewhere. If we had an amount of lives we wanted to keep track of, that would be a variable. If we had a position on a screen we want to keep track of, that would be a variable. Anything that we want to hang on to and remember from one frame to the next, we're going to use a variable for, or if we want to calculate values, or you'll sort of understand these more from context. The first code we're going to write is always going to be a little weird because we don't have context yet for how it fits in. The more we write, the more you're going to see some simple patterns of how the stuff's getting used and what it's doing for us. And then we're creating a fill style black onto our canvas, context, the graphical sort of underpinnings. And then we're calling fill rect with 4 numbers. 0, 0 is an X and Y or horizontal vertical coordinate of the top left corner. Canvas width is getting this number, 800 pixels. Canvas height is getting that number, 600 pixels, which corresponds to the bottom right corner. Now you want to pay attention to this because in classical math classes like geometry or trigonometry or most kind of graphing, you'll typically see increase in Y value or increase in vertical position be raising it on the screen. It's actually the opposite in a lot of computer graphics and game programming. So just to show you what I mean, like here I'm going to say fill style after this, and let's say red. And now let's set a position that says 100 pixels from the left, 200 pixels from the top. Let's make a box which is 50 pixels wide and 25 pixels tall. Notice too that the way fill style works is it's referring to setting the color for the fill rect call that comes after it. So even though it's happening over 2 different lines, it's kind of setting up the graphics and then doing something with it. You'll see more of that in a moment. So I'm going to save it with Control S, or as always, you can go to File, Save, refresh it in the browser, and I now see this red rectangle, which we know from the code must be 100 pixels from the left, 200 pixels from the top. Does that make sense to us? As a corner of this looks to be about half as far this way as it is from top to bottom there. And then 50 by 25. Is it about twice as wide as it is tall? It must be, right? And so let's say we want to move that over a little more. We could say 120. Save the file, refresh. You'll see it bumped over a little bit. I could say 200. Save it, refresh. And now it's jumped over a little further. And we could draw another rectangle if we wanted. Let's say we want to make one that's green. And so we remember the first 2 values are how far from the left and the top, your top left corner of your rectangle are. So let's say we want to move this one over 30 pixels to the right and 30 pixels down. This is 200 pixels from the top, 25 tall. So this should have a little gap. 225 would be the bottom of that one. And let's make this one a little 10 by 10 green square. I'm going to save it, refresh it, and there's our little green square. The important part is to be able to practice and get a sense for these coordinates. Like, okay, if I want to draw something in the middle of the screen, where would I put it? Okay, well, let's think about that for a second. If I want to put this green square in the center of the screen, let's make it a, let's make it a white square so it's going to be easier to see. What's the center? Well, if the window is 800 pixels wide and 600 pixels tall, then what's half of 800? 400, right? So we'll make this position, let's just try 400. And okay, it's the total canvas's area vertically, we know is 600 because that's what we set it to here. So half of that is 300. And let's make our rectangle a little bit bigger so we can better see. Let's make it 40 by 40 so we can better see it. And when I refresh it, is that white box in the center of the canvas? Kind of. Let me show you what I mean by that. If we make this box even bigger, it'll be more obvious. Let's say I make this box 200 by 200. Refresh. Remember, what these first 2 values set is actually the top left corner of the box, with the third and fourth one set are its size. So if we want the whole thing centered, then we actually want to subtract half of it on each direction. So like if it's starting in the middle and going 200 pixels over, we want to bump it 100 pixels left, or half of its width to the left, and half of its height up. 300 by 200, refresh, and now that white box is centered. It's all a little messy, it's all a little headachy at first if you're new to this stuff. Again, you'll see more as we move forward on how the ball is behaving, on how the paddle is working. But if you have any doubts at all about your positions or your shapes, play with these numbers. Try putting boxes in different positions. Try to see if you can line them up corner to corner, edge to edge. Experiment for a bit with it. You'll get a lot more comfortable with how this space is laid out. Now, the other thing to know is that the order that we draw shapes in code depends on what overlaps what. So, right now, like let's say here's our white box and here's our red box. Let's say I want to move this white box over to 225 and 210. Those are positions that I can see will overlap the red because this is going 200 to 250. This is 225. This is going vertically 200 pixels down to 225. 210 is in the middle of those-ish. So in refresh, you'll see that the white box is overlapping the red box. That's because this white box is getting drawn later than the red box, so it's painting over it. If I switch their order, I'm using shift and up and down arrow to select line at a time in a text editor. Shift and up and down to select those arrows, up and down arrows. I'm going to cut it with Control X and paste it with Control V. And so now I'm going to draw the white box and then the red box, and we should expect that when I refresh the browser after saving my file, red overlaps the white. So draw order is very important. This is especially a big deal because if I drew this black part last, which is drawing the full size of our canvas, again, just Control X to cut, Control V to paste, saving it, I won't see those other shapes at all because it's getting covered over by this black box. Move it back to the top. Notice too that in these, I can use these values like canvas width and canvas height because we know what those numbers are. So what I mean by that is when I centered it, what I could have said, instead of trying to do the math in my head of like what's 800 divided by 2, I could have said canvas width divided by 2, and that'll do for us. It'll divide 800 by 2, and it'll give us 400. So now our rectangle red positioned horizontally, about centered, again, not accounting for the box's size. So that's just how to position some graphical elements on the screen, and we're going to be moving towards is getting them to move on their own. Before we do that, we're going to move all of our draw functions over into their own block of code, because this is all getting pretty complicated. Like, we don't want all of our draw stuff happening along with the rest of our game's logic.